with you all what are those learning outcome in this calculus. Okay, there are three main one. So every time for the lecture, I think first hour we should do for the live session. That means all of you must attend the first hour class. Okay. Then in this first hour class, I will ask some question in the class, and then I teach the corresponding topics for each week. And sometimes I will not record. Throughout the session, because the video take very long time. It take longer time for upload too much, and therefore I will take some of the videos for some examples that we have discussed here. Okay, I will split into few videos. Okay, but not all the videos to be shared, and therefore please attend the class. All right, for the first hour during our lecture. Then for the tutorial class, then only we will further discuss for the question that we have done. Okay.
DMR, yeah. DMR, 20 people came in already.
DMR, how many students?
20 people.
20. They're all here.
Yep.
Then how about DMG? Any cross rep can tell? How about your group?
Wait, I'm still still calculating.
And DE also?
Sir, DMG all here.
Sorry, sir.
DMG all here.
Yeah, DMG all here.
So left DEE, how many students? Who's the girl that talked with me just now?
Oh, I'm CY.
Oh, CY. Okay, CY. How about your group? How many students are there?
Still counting. Hey Sam.
Yeah.
You here? Okay.
Yeah.
Cross rep.
I will come.
So how many are there?
Got 7 here.
You mean total will be 7?
Total is 7. Yeah.
Oh, total is 7. Okay, so how about DMG? Okay, so I'm start to share my screen now, okay, about this course. So everyone can see my screen? Okay, so I think I will start now. Okay, so we will first, I'm going to first review about this, the thing that we're going to learn in this semester, okay? So I'm going to record the video, yeah? Okay, so basically in this course, we are having 3 learning outcomes. The first one is to find the limit of function and also identify the existence of the limit, okay? That will be the first topic that we will learn, which is for the first week. I think I'm going to use 1 week, 1 week time to do the first learning outcome. Okay, because the rest of the other 2 will be need more time for that. Okay, we will have 3 main topic. The first one that I'm talking about will be limit and the function continuity. All right, that will be the fundamental understanding. How do we get this? The second one that we learn is actually differentiation, the second topic. That will be the second topic. Okay, differentiation. Okay, so from this differentiation, we will learn that their application, like we are having a drawing graph. Okay, we still remember we have sketching the graph, finding the rate of changes, and also the optimization. Okay, have you learned that three area before?
Yes.
Sketch graph, optimization, okay, together with this rate of changes. And lastly, also we'll learn some integration, the third part, which is meant for to find the area and also the volume. Okay, so that will be our 3 learning outcomes. So for each week, okay, so maybe I copy this one to a notes. Okay, to notes. Okay, we have 3 learning outcomes. Okay, so for lecture hour, we have here will be 2 hours per week. Okay, and then secondly, we have the tutorial class will be 1 hour time. Okay, so the tutorial class will be the main one, which after this lesson, after the lecture lesson, okay, you have to answer all the questions given. You have to answer all the questions given in the tutorial. Okay, answer all questions and submit your work. Okay, I will say weekly. All right, to gain the attendance, you must submit the tutorial questions to gain your attendance. Okay, for this 1.5 hours time, you need to finish all the questions that I have given in this tutorial. All right, so tomorrow, I think tomorrow class, we have one coming DMG class, DMG, 1:30 to 3 p.m. After you have listened to this lecture, then you have to start doing your tutorial, and then we have discussion in tomorrow, 1:30 to 3. After you finish it, then only you submit and to show that you have done everything, then only you can gain your attendance. Okay, I will take attendance for tutorial, but not for lecture. Okay.
Sir, tomorrow is not DMG. We had our class just yesterday.
Is it? Oh, okay, DMR. Sorry, DMR. DMR. Okay. So what else to be? Okay, I think that's it for the for how we conduct the class. Okay, so I think we will start now. We'll start doing our first lecture now. All right. Okay. Wait. Okay, I'm going to start now, right? So if you have anything, you may unmute yourself to ask. It will be better. Because when I sharing a screen, normally I will seldom see the chat here, because I will always refer to the. I'm referring to the lecture notes that I prepared accordingly. So please unmute yourself to ask a question. Okay. So can I start now?
Yes, sir.
Okay. So for the first lesson here, okay, we're going to learn about these limits and continuity. All right. Okay. So the limits function is actually the fundamental to understanding about this calculus. While calculus, as what we have learned, as what we have mentioned just now, is actually split into two parts. One will be differentiation. Okay, together with another one will be integration. Okay, so that will be two main field of this calculus. All right, maybe starting from here we can do some recording. Yeah. So for differentiation, the application that we will going to learn will be, the application for differentiation. We're going to learn how do we use differentiation method for doing this curve sketching, optimization, and also as well as the rate of changes. That actually referring to the method of differentiation. Okay, while the computation of area together with volume as well. Okay, that will actually referring to the skill that you have learned in this integration. All right, okay. So the limit is actually distinguish the calculus from algebra. Okay, we are using the algebra to learn this limit here. To learn this calculus here. All right, okay. So the first one that we're going to learn about the concept is we would like to see for a random function fx. For a random function fx, for any function random, any function random fx. Okay. Okay, for any function y equals to fx. Okay, I'm going to take a point here when x equals, when x approaches a c value, all right, we would like to see what is the corresponding y approaches value. Okay, let's say it will approach L, and therefore if y approaches an L value, okay, so that this relationship we can write it as a limit for x approaches a c value. All right, the corresponding fx will, the fx is y itself. The y approaches L and therefore will equals to L. Okay, that will be the format that we're going to write in the limits. Okay, the limit of x is as x approaches, the y will approaches L. That will be the format of the limit we have right here. Okay, understand? So now we can go into the first example. Okay, so for example here, example number 1. If we have the fx, fx is a y. Y equals to x plus 2. All right. Okay. For this function that we have here is actually considered as we call it as a continuous. It is continuous. Okay, at any x value. Okay, which means that when we substitute any x value to it, when we substitute x equal to, we can find we can know what is the corresponding y, which is 4. X with 3, we get 3 plus 2, we get 5, so on and so forth. Okay, we can get any y value by substituting x into it. Okay, now if we want to study a particular one, okay, which is if you want to find limit x approaches 1, the fx value. Okay, so I will take some point here. Okay, can you see this relationship or not? About this input. Okay, when there's an input of x value, which is approached 1 from the left, which means that when x equals 0.9, 0.99 or 0.999, okay, when x is getting nearer to that 1 value, okay, for example, if I zoom into here to make, okay, I put some point, I put some point which is near to from the left, at point A, point B, and point C. Okay, for example, I'm having point A, B, and C for comparison. Okay, point A, for example, point A is let's say we have a point 9. Then the corresponding y will be 2.9. Okay, and when point B getting close to 1, whereby B is having coordinate of 0.999, for example, then we have 2.999, isn't it? Okay, and C, while C even close to the value of 1. Okay, so the corresponding will be 2.9. Okay, therefore, these 3 lines, I mean these 3 points, these 3 points from the left, we will say that when X is approaches 1, okay, I will put a negative sign on left top of it, of 1. Can you see a negative sign here, class? Can you see that?
Yes.
Okay, I put a negative sign to represent. This is representing the X is approaches 1 from the left. Okay, and therefore we can write that limit. We can write that limit in terms of limit X approaches 1 negative fx, which is from the left for this function x plus 2. Then from the graph, we can see that the corresponding y value, which is 2.9, 2.99, and 2. Okay, we have 5 nines also considered as it is actually near to a certain value of 3. Okay, can you understand it? Do you have any question up to this point?
Jerk, can you like make it clearer a bit?
Yes. You mean the picture or what? Sorry? And anyone have any question up to this point? Can you ask ask now, Desmond?
I'm asking for the what's that? The tutorial. Tutorial need to write on the paper, ma. Can I write on a tablet and pass it out on PDF format?
Yes, you can write on tablet as long as you can convert it in terms of this soft copy to be submit online, so that I
Okay,
can
sure.
take over through Google Classroom. Yes, please.
Okay.
Yes, and okay, as long as it's okay, we will say that as long as this one is a continuous function, okay, for finding the limit, what we can do here, we will just substitute the corresponding purchase value of x here. Okay, so for example, the first question, if it asks us to find the limit fx x approaches 1, we can just write as limit when x approaches 1. Okay, then the fx I'm going to substitute with this given x plus 2. You see that? Okay, x plus 2, which is, then next I'm going to substitute 1 into it. We get 1 plus 2 and get 3 will be our limit value. Understand?
Sir, when you submit the one, it's from the graph, right?
Yes, yes.
Okay.
Yes, because it's a continuous and we can see from the graph when it getting near to 1 from the left side, you can see my arrow or not? From the left side, we will write that as a format that limit x approach 1, we put a negative sign. We put a negative sign to represent x approach 1 from left. Okay, and on the other hand, we have also some points getting closer to that point as well. Okay, and this blue one will actually can be denoted by this limit x approaches 1, and we have a positive sign on top of 1. Can you all see that? And that positive 1 is actually represent x approach 1 from right side. Can you understand? Yes or no? Yes,
Yes.
huh? Okay, if both of the direction are having the same coincident y value, which is 3, and therefore we can write as this for, this concept is, if we have the left side limit fx equals to the right side limit, then we will say that limit at that particular point will be their corresponding, okay, same value, which is 3. Okay, but for our workings, what I mentioned here, as long as I know that this is a kind of so-called continuous function, then we will just write in such a way that limit fx will then equal to limit x approaches 1, x plus 2, and then we will just booking it by substitution. Substitute x equal to 1 into it, then we get 3. Understand?
Okay, thank you, sir.
Yes, okay. So if you have any question, please feel free to ask, okay? That I can have a further discuss. All right. So the next 3 questions here, maybe you can, okay, when throughout this lecture, you can drop down some notes also together with me. It'll be more easier for you to do the tutorial question later on, because this lecture example will actually some similar example which reflects in your tutorial. If you're able to do my lecture together with me, then later on when you do tutorial, it will be similar questions. Okay, so for question B here also, question B, if you want to find the limit for this function x, fx is, this one is a kind of quadratic, isn't it? Yes or no? Remember this one, fx is equals to x squared. That is a quadratic function, isn't it? Okay, it's actually look like this, isn't it? Y equals to x squared minus 3x plus 1, isn't it? Okay, so for this particular function, when x equals to 1, we'd like to know for x equals to 1, what will be the corresponding approaches y value, isn't it? Okay, that is the question. All right, so I know since it is actually a continuous function, do not have any break or hole, is a continuous function, and therefore for this question I will just substitute, okay, x squared minus 3x plus 1. I will just substitute 1 into it. We get 1 squared minus 3 times 1 plus 1, okay, which is minus 2. Okay, got it? Yes or no? Yes, huh?
Yes.
Yes.
Okay. While for question B, okay, for question B, it is actually an absolute function. Okay, maybe you can help. You can draw this. You can sketch this together with me. This one is when x when this is 1. When x equals to 1, it will be 0. Okay, this is a graph. Look like this. You can sketch a graph by having some point, by giving some point. All right, you have x equals to 0, then the fx will be positive 1, 1 will be 0. When it's 2, will be 1. Then we have these 2 points. Okay, so if the question asking about what is the limit, okay, if the question asks about what's the limit of x approaches 0, if we see from the graph here, okay, we have the left limit and right limit. They're actually considered at the same point, isn't it? Which is the value of 1. Correct or not? Okay, but however, we do not actually need to write it down. I just want to show you the concept saying that as long as it's a continuous function, therefore, as long as a continuous function, therefore, we actually can do it by just substituting. By just substituting that particular x approach value into that function. Then we get this. All right, okay. Something to highlight is when you have start substituting, when you have already started substituting, at this point the limit value supposed to be eliminated. Okay, you do not need to write the limits. All right, and here we get absolute -1, we get +1. Okay, which is the point value of y that is same as what we can see from the graph. Understand? Yes or no?
Yes.
Up to this point, do you still have any question? Anyone? Please ask now. Okay, it will be easier for you to do your coming tutorial question.
Sir, the answer for B, right? Isn't it -1?
You have an absolute function. You have an absolute value. Then become +1.
I mean B, not C.
The B.
Oh,
Example
B.
one.
Oh, sorry, B. Okay. I did some wrong. I mean -1. Yeah, thank you. Thanks. Okay. So donkey. How about donkey? Okay, for this third x plus 2, x plus 2, if you learned before, is actually having -2. The graph should be drawn at this format. The graph has been drawn at this format. Okay, y equal to third x plus 2. Okay, for sketching graph, if you know how to sketch graph, you are allowed to go to the website of Desmos to check this graph for understanding. Okay, you may go to Desmos calculator. Okay, Desmos calculator, and then you can draw this y equals to x plus 2, isn't it? Something wrong. Y equals the square root of x plus 2. Yes, that's the one. Okay, if you have this graph, okay, I just want to show you this graph. Okay, for this donkey, this particular graph here, for this function, I will say that. Yes, can you listen to me? Can you hear me? Yes,
Yeah. Yes.
Okay, I just would like to tell more detail about this function. Okay, because if I draw this function here, y equals to square root x plus 2. Okay, I would say that y is continuous, starting from for the domain of x larger and equals to -2. Everyone understand? Everyone understand about this statement? Yes or no?
Yes.
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 Because we only can see the value of y starting from x larger and equals to -2, isn't it? When x equals to -3, y is undefined. Agree or not? Yes,
Yes.
y is undefined. Okay. When it is y equals to -2, when x equals to -2, we have the y as well. The y is defined as well. Y equals to what? The y will be equals to third -2 plus 2, which is 0, isn't it? Yes or no?
Yes.
Yes, okay. So one thing to highlight to you all is, okay, if I go back to this question, This question is actually only asking for a particular point whereby x equals 7, isn't it? 7, right? So this question is only asked about that particular when x approaches 7. And from the graph itself, we can see from here, when it is 7, for this particular point, you can see the corresponding y is actually approaches a value of what? Cy? What will be this value? Cy from DE? Yes or no? Can you understand or not? Cy?
Y equals to 3.
3, yes or no?
Yes.
Yes, okay, because if we work out in such a way saying that, okay, limit the x approaches 7, then we have cert 7 plus 3, isn't it? Can I write in such a way? Correct or not? Can I write in this way?
Yes.
Yes.
Cannot,
No.
Cannot,
Huh?
because you already start to substitute, isn't it?
Oh,
Okay.
Understood.
And therefore, again, to remind you again about the format wise, you should write as, okay, before you go into substitute, you have this function, isn't it? When it is still unknown x here, I'm still having a limit. But when we start to substitute that time, we do not need to write that anymore. Okay? And then we start to substitute to get this value 9, which is 3. Understand what I'm saying?
Understood.
Yes, okay, so sync hub, isn't it? Chuan hub or sync hub? The DMG.
Yeah, yes, sir.
Okay.
Chuan hub.
Can you tell, how about if I want you to find the limit x -2, do we have this or not?
Sorry, I was lagging. Limit what?
Limit x approaches -2 fx will be equal to
square root 0.
equal to. Can we substitute for this point? Can we substitute for this point? Class?
Can.
Cannot. Cannot. We cannot substitute. Why? Okay, because we only have a limit from the right. Can you see or not? If the question asks us to find the limit -2 from the right, yes, you may substitute. Which is -2 plus 2, you get 0. All right, but however, do we have any point which is getting nearer to the left? Do we have any point here? Yes or no?
No.
No, isn't it? That means when you have x equals to -2.01, your y is undefined. If your y is undefined, that means the limit from the left is actually undefined for this case. Understand? Everyone understand?
Yes.
Can you see the negative sign here? The negative and the positive sign actually make a much difference. Okay, if it is negative, means that it's from the left side. From the left side, if you do not have any points, that means you do not have that limits. It will be undefined. Okay? Everyone clear?
Yes.
Yes.
Okay, you need to get this clear because it's very helpful for us to learn for the following subtopic, especially the left and right limits. Okay? Yes, all right, I think I will stop at this one point first to to give you guys to have some stop recording. Okay. Do you have any question to ask up to this point? For these few examples that we discussed?
So like just now, if it didn't state any sign or anything, so meaning is it is safe for us to just say that it is undefined lah.
You mean this one?
Yeah.
For this one?
Yeah, if it did state any sign for the -2, so it is safe for us to decide that it is undefined, right?
Yes, yes, yes.
Oh, okay.
If the question asks to find the x approaches to fx, for example, if I change my question to be -2, -2, because what we can study is because of when we have x -2 from the left side, that particular function, I mean that particular limits does not exist. Okay, and therefore we have also does not exist. DNE stand for does not exist. Okay, understand?
Okay, I understand. Thank you, sir.
Yeah. Or unless the question asks in the other way, such that if you have positive sign on top. Okay, you see that positive sign? A positive sign means that it will still define on from the right, and therefore we still can substitute -2 into it, which is 0. Okay? Yes,
Okay.
Yes, because if for the point that is from the right side, we still are having some point which is close from the right side. Okay, from the right side. But we do not have any point from the left side. We do not have any point. That's what I'm saying. We do not have any point from the right, I mean from the left side. Okay, and therefore we were just saying that from the left side one, we do not have that limit. Okay, does not exist. Yes, so I'm going to copy down this one to be uploaded later on. Okay. Right. So the next one will be, okay, these are the workings. Okay, as long as continuous, you may just substitute them. Okay. But however, okay, when it comes to E, F, and G, okay, we'll continue. For E, F, and G, we have sine x, cosine 2x. This one still consider we can substitute. For both of these, we will just substituting. Okay, if we want to find the limit for this, we will write sine pi over 3 plus cosine 2 pi over 3, isn't it? Okay, and for the second one also, we are substituting also 2 times 2 plus 1, which we will get 5. Okay, yes, all right. Then for this one, sine pi over 3, remember in calculus, normally all the angle that we are going to substituting the unit in terms of, all their unit are in terms of radian. Okay, so please remember that when we want to get this value, you have to convert yours calculator in terms of the second one, radian. Then only we start to key in accordingly. Okay, pi over 3. Then add up with cosine 2 pi over 3, which is this value. Okay, which is 0.3660 value. Understand? Unless have you actually memorized this before? Anyone? Any one of you have memorized this before?
Forgot already.
Anyone? Or else you may also write in terms of third form. I also will accept. This one will be more accurate if you ask me. Okay, This one is actually you have rounding off. You are doing the rounding. Unless you can write it in these terms, also can. Understand? All right. If you remember what is sub 3 over 2, that is actually equals to sine 60 degree. Follow? Yes, sir. Okay, we can start to record some part. Okay. Yeah, can we continue? Yes. All right. So, okay, when come to the with the concept that I have discussed just now with the square root function here, and now if we have a reciprocal function whereby y equals to 1 over x, this is y equals to 1 over x for this function. Okay, for this function, for this particular one here, we're still able to know the limit, isn't it? Okay, we're still able to know the limit from the right. You see a point. From the right, you see a point. And from the left also, it will approaches the same point. Isn't it? Correct or not? Okay, so both left and right, they are also approaches the same value of 1. Okay, and therefore we will say that that limit x approaches 1 for this function 1 over x is actually we can still doing substitution. The substitution still allowed because it is continuous at that particular point. Okay, which is equals to 1. Understand? Can you follow? Understand what I'm saying?
Yes.
Yes.
Yes, okay, so that is a very important concept, saying that when we see from the graph, okay, we know that at that particular point, if x is the y is continuous at a particular point, we can just doing substitution. Okay, but for question 2 here, when x approaches 0, what we can see is if we analyze from the right side, we're having the arrow. The y is what? Going to be positive infinity, isn't it? Agree, huh?
Yes.
Yes, okay, and therefore, this limit when x approaches 0 from the right, fx will be positive infinity. That is how I write the thing. Okay? In contrast, if we compare when the x approaches 0 from the left, you will see this arrow, isn't it? Okay? But it will approach what? Negative infinity. Okay, and therefore, this can be written as x approaches 0 from the left, fx will equals to negative infinity. Okay, and both are actually because both the infinity and infinity actually is not a specific value. It's not a specific value. If it is not a specific value, and therefore both is actually undefined value, and therefore we can comment that both is actually does not exist. Okay, and which makes the limit x approaches 0 also does not exist. Understand? Yeah, because they are not meeting at the same value. When x approaches c, they are not meeting at the same value, and therefore we can say that for that limit, when x approaches 0, fx does not exist. Okay? Can you follow?
Yes.
Yes,
Yep.
Okay, all right. So now let's go to the next one. Okay, for example 2 here, okay, that will be a special function. It looks like a quadratic, but however, it actually has a factor of, the denominator to be x minus 1. when we want to find that limit, okay, we will try our first method to substitute. When we try to substitute 1 into it, when we try to substitute into the denominator, we have 1 minus 1 equals to 0, isn't it? All right. When we have that situation, okay, we cannot do substitution. Okay, we cannot do substitution. And therefore, we need to do factorization for the numerator. Okay, to get the same factor which is same as, okay, the denominator to be cancelled out. Once we have this, the function to be x plus 2, at this point, then only we can substitute 1 into it. Okay, then we get 1 plus 2, that will be 3. Okay, right, that is the method that we're going to do. Okay, that means whenever we substitute whenever we substitute the c value into this function itself, if making the denominator, if the denominator, when we're doing the substitution, the denominator equals to 0, then we have to do factorization. Okay, to do the simplification. All right. So once we have that to be simplified, then only we have the function to be, then only we can substitute x into it to get the corresponding limit value. Okay, that will be the workings that we can working out. Okay, but however, if we really draw it into a graph, it will be see more clearly. Okay, that means for this graph, it's actually you're having a hole at that particular point. Okay, that means when x equals to 1, y is actually undefined. The y is undefined at x equals to 1, but the limit can exist. The limit can exist. Okay, because based on what we have learned from the limit is, we actually want to see when your x value approaches a certain value. Okay, when you have your x approaches from the left to this x value of 1, okay, even we do not have this f1 value undefined, even the f1 is undefined, but we still can see the y is actually approaches the same value, isn't it? They are approaching a same value. All right. Okay, if they are approaching the same value, and therefore the limit still can be defined. The limit of x approaches 1 still can be defined as 3. Understand? Any question up to this point? Yes. Anyone? Any question up to this point?
No.
Noah? Okay. Sometimes the question also, okay, sometimes we also having a graph. Okay, for example, the next one. This question. Okay. When we have the function, okay, the hx equals to this function. All right. H, when x equals to 1, it will be this point. When x equals to 1, will be this point. But when we want to find the limit, again, what is the concept of limit is what? The concept of limit is when x approaches the value of 1, we want to see why we're approaching what value. And that value is not 2. It's supposed to referring back to the function here. Okay, whereby we can see from the left side when we have some point getting near to that point, and from the left and right, there are two of this direction also approaching the same value, which is 3. 3 is our value. Okay, And therefore, how do we find the limit will be in this way, all right, which is when we want to find the limit at that particular point, we have to substitute this function into it. Okay, we substitute this function into it. And then we try our first method, which is we try to substitute 1 into this denominator, and then we have 0 of that, isn't it? And therefore, we cannot doing substitution. Okay, therefore, the next step will be we are going to do the factorization instead. Can you see or not? Okay, we're going to factor out, saying that we have x squared plus 2 plus x minus 2 equals to x plus 2 max minus 1 to be having the same factor, same as your denominator to be cancelled out. Okay, so once I have simplified into x plus 2, then only we can substitute 1 into this function. Okay, here we have 1 plus 2, and therefore, which is 3. Same as what we have seen from the graph. Understand? Any question up to this point? Yes or no?
No question.
Can you understand?
Yeah.
Yes, sir. Yes, sir. Okay. So I think we will continue. All right, we continue. All right. So the next session will be some concept or properties for the example 3. Okay. Now I'm going to I will share this as well. Okay. So the example 3, if say we have this x squared minus 4 x minus 2. When we're doing the substitution, when we do the substitution, this will be 2 minus 2 equals 0. Then we cannot do this substitution. Okay, and therefore the way to work this out will be we're actually doing the factorization from this x squared minus 4 into x plus 2 and x minus 2, isn't it? Okay, do you still remember about this formula? No? I mean the a squared minus b squared equals to what? A plus b times a minus b, isn't it? Yes, okay, that is how I get a plus b. Then I can cancel this x minus 2. Once I have this one, x2 plus 2 to be substitution, then we get 4. Okay, similar to the question B as well. Question B will be x squared plus 3x minus 10, and the limit x plus 5 and x minus 2. Okay, once we have this x plus 5, we can cancel the x plus 5. Okay, then we get this x minus 2 to be substitute -5 into it. Then we get -7. All right. Anyone follow? Yes or no?
Understood.
Yes.
Yes, sir. Okay, Desmond, how about the question C? How about question C?
Yes.
How do we do question C?
Factorize the first, the numerator.
The numerator. Okay. How do I factorize?
I use
Can we
calculator.
factorize the 2? X minus 2, isn't it? Correct or not?
Yeah.
Then how about the denominator?
Hold on.
Yes, please. We can. What is the highest common factor of x cubed and x squared?
X squared.
I using calculator. I got
X squared. This one do not need calculator. This one just a simple 2 terms only, which we can factor out x squared. If you factor out x squared, then what will be the left term for the first term?
X minus 2.
It will be x for this term, isn't it?
yeah.
Okay, and then the other one will be left only 2 ma. Correct or not?
X minus 2.
Yes, correct. Okay. You can see both of them is actually having a particular factor. This factor is making the denominator to be 0, isn't it? Okay, both of the numerator and this denominator should have this factor to be cancelled out.
Yeah.
Yeah. And therefore, now you can now starting to substitute 2 into it, and then we get the final answer be 1/2. Understand?
Okay.
Yes, okay. So I'm going to copy this example answer into our our reference later on. Okay. So the next one again, for this fx, for this limit, this one is so called a piecewise function, the piecewise function. All right. So for this piecewise function, if you want to find the limit x approaches to the fx value, okay, I draw again for this for your reference. This is actually can be drawn as a, we have a xy axis, and you have a function of y equals to x. This is y equal to x. All right. But for a particular point when x equal to 2, here you have a hole. Because when x equal to 2, it does not equal to 2, but equals to 3. You have a point here. That will be 3. You see or not? Okay. This point is referring to this domain where x equal to 2, the y will equal to 3. Understand? Okay. But when we want to find the limit, when we want to find the limit, we are still referring back to this function, isn't it? From the left and right, they are actually approaches a value of 2. Okay, which means that when we want to find the limit, we are still substituting the function fx to be this function x. Okay, which is 2. Understand?
Yes.
Yes, this concept is very, very important. Okay, very important for the for the later example. Okay, the limit is not only the FC value. Sometimes we are still having to have you refer back to the graph function to see it's actually when your x approaches a certain value, what is the y value approaches. Okay. Yeah. All right. So we are still having some more examples. Okay. So when come to these polynomial with degree 3, okay, that actually we have some other way which I allow you to use the calculator if you want. Okay, if you have x power of 3, okay, maybe this one I use calculator to show you. Okay, this one if you want to do factorization of degree 3, all right, you may use your calculator. Okay, so this will be 3x cubed plus bx squared plus cx plus d equals to 0. Let's say I would like to solve this solve this higher degree of equation. Okay, we have 1 times x cubed plus 2 times x squared minus x and then minus d2 equals 0, isn't it? Okay, and therefore I can use my calculator. Okay, I press equation 1, and then I have only one unknown, isn't it? And therefore I have to press this to the right button. Okay, I press to the right button and we'll select degree of 3, because the highest degree of this will be degree 3, isn't it? All right, so I press 3, and now I may start to key in. My A will be I'm going to key in 1 for that. I press 1 and press equals. My B will be 2. I press 2 and press equals. Okay, and my C, okay, and my C will be -1, isn't it? -1, all right, equals, and lastly, our D will be -2. Okay, and therefore we have X equals to 1, we have X equals to 1, and also we have X equals to -2, right? And X equal to -3. Okay, yes, we have 3 roots. We have 1, -2, and -1. All right. Okay, and this, if we write it back, it will be X minus 1 equals 0, and this will be X plus 2 equals 0, and that will be X plus 1 equals 0. And next, we'll put these 3 factors together. It will be X minus 1, X plus 2, and X plus 1 equal to 0. Okay, that means when we want to do this limit, this limit, when we want to do the factorization, we actually can factor the numerator. We can factor this numerator into X minus 1, X plus 2, and X plus 1. Okay, which they are having together with the numerator having a same X minus 1 to be cancel out, isn't it? Yes or no? We can cancel X minus 1. Yes, okay, once we have cancelled out, and now we can start to do substitution. Okay, that is how I get the limit of 6. Understand?
Yes.
Everyone understand?
Yes.
Yes, okay. There'll be another method which is so-called the synthetic division. That synthetic division I'm going to teach during the tutorial class. For yesterday's class, I already taught them. Okay. So for the synthetic division, I'm going to cover it during tutorial class. Okay, for each group. Yes, so for all I'm going to teach you, you can use calculator, all right, to know your the roots, and then to get back this factor accordingly. Okay. Yeah. All right. So that will be for question E. Question E, okay. And right now we have question F also. Okay, the question F here. Maybe I show the workings here. Okay, for question F, for question F, if we substitute 6 into both denominator, we have a 0, isn't it? And therefore, we have to do combining those fractions. Okay, if you do combining, therefore the second fraction, you have to add another one, which is X minus 1 for both numerator and denominator. Okay, so once we are having the same denominator, all right, then we can combine their numerator. Yes, okay, to become this form. Okay, again, if I check, the factor that will make it to be 0 will be X minus 6, isn't it? Then I will say that this supposed to have X minus 6 as their factor as well. Okay, so that I will factorize again to get X minus 6, same as the denominator side, to do the simplification. Okay, once I simplified it into this one, the latest one of the function of X plus 2, X minus 1, at this point, you can substitute 6 into this. That is how we can get 6 plus 2 and 6 minus 1, which is 8/5. Understand? Okay. Can everyone follow? Yes, Yes, sir. Okay. And the next one will be, okay, here. This one, we have x cubed, 2x squared plus 5, and then we have this second fraction and the third fraction. Okay, if we're doing the substitution, okay, I will always substitute to their denominator. See whether it will become 0 or not. Okay, if I substitute to this one, okay, when I substitute into this one, it will be 1 minus 3 equals to -2, isn't it? Not equal to 0, isn't it? That means you actually can able to substitute into this term. Okay, but when you substitute to the last term, whereby it will make it to be a 0, okay, therefore, we only will do that simplification. Okay, we only do this simplification to make every terms, okay, become, when you sub 1 into their denominator, it will not become 0. Isn't it? Okay, when it not becomes 0, that means you can sub 1 into all terms. That is how it works. Understand? Instead of combining all of them, combining all of them will be more complex. We do not need to do that. Okay, and therefore we only need to simplify this last term. Only the last term. Okay, whereby this is having x minus 1 to be cancelled out. Once we cancel out this, starting from this step, we can just substitute 1 into it. Okay, to get your limit value. Understand? Anyone follow?
Yes.
Yes.
Yes, all right. So I think that's it for this example 2. Example 3, I think. Yes. Okay. So any question up to this one? Do you have any question up to this point? How to find limits for this kind of question?
No.
No, yes, yes. Any question?
So far, no question.
No, okay. Now we may proceed to the 1.2. Properties of the limits. Okay, so for these properties of limits, okay, when we have a fx function plus gf function, or we have a constant k, we can actually pull the constant k out. Okay, or when it's plus or minus, we actually can find those limits individually, then only we add them up. Okay, so for this kind of question, normally it will give us the fx equal to 5 and gx limit equal to -2. And therefore, from what we have here, okay, I'm going to discuss, I'm going to record some video down. Okay, so for this kind of question, you have to write the terms that given in the question, which is, if the question gives us a limit fx, and also as well as the limit gx, that will be our second condition. Okay, we have first and second condition. All right, so for the first question, we will try to split them into this format. Okay, fx and then minus limit x approaches 3 gx. You see that or not? Okay, so and then only we start to find their limit separately. This equals to 3, but just substitute 3 into it, we get 3. All right, okay, and this limit gx fx we actually refer back to this, isn't it? Which is given equals to 5. All right, and the last one here, this is gx limit, which is equals to -2. Okay, and therefore we have 15 plus 2, which is 17. Understand? Anyone can follow?
Understood.
Yes,
Yeah.
Okay. You have to make sure that you have to have this step to show me that you have split them to find those limits separately. Then only we're doing the substitution. Okay, it will be same for the B, C, and D as well. Right. So for B, I'm going to write it down as a limit gx plus 2. That will be a constant, isn't it? And when we want to find the limit 3x, the 3 can be pulled out, and then we find the limit x as well. Okay, that would be the question B. Okay, how do we work in that way? Also, the question C and D, when you have a power of cube, right? You can take, you can make a big bracket at the outside. We have a cube root, the cube here, the power of cube here, and then we have a 3 limit fx inside. So by having this given fx limit value 5, therefore that is how we get this, the last answer. Okay, same for the last one, we actually can have this cube root outside and also the power of 4 to be done, to be do later. All right, we can just substitute this to become -2 into it, and then power of 4 becomes 16, and then we have cube root 16. All right, that will be this part. Okay. Yes, sir. Any question? For this part?
No, sir.
No, Okay, the second properties of limit will be just a very simple one. So the numerical question I will give will be in such a way. That's the one. Okay, then when come to the one-sided limit, okay, this one is what I have discussed very earlier. Now you know how to see this format, isn't it? From the right and from the left. Okay, and basically this question, one-sided limit, we will always referring to the graph here. Okay, so for example, this question, okay, I'm going to record this question again. We can study this graph function. Okay, so now we're going to start with this one. Okay, this example. All right. Okay. So maybe can I ask someone about this positive sign here? Can we have some discussion? Anyone? Wong Li Chen. Are you here, Wong Li Chen?
Yes.
Okay, Li Chen, do you know how to see this positive sign here?
Huh?
Do you know how to see this positive sign here?
See the 0 from the right side.
On the right side, okay. That means for answering this question, x approaches 0 from the right side, fx will actually equals to what value? Can we see from this graph?
Equal to 1.
Equals to 1, Can see very clearly, Can you see my arrow or not?
Yes.
Everyone can see, You can see we actually having when your x approaches to this 1, isn't it? That would be our 1 value. Yes, okay, so now for this one we have a value of 1. Yeah, correct. Okay, so thank you. Maybe I'll ask someone else. Okay, how about limit x approaches 1? Can anyone answer? Any volunteer to answer this question? Do we have such a limit or not? Yes or no?
No.
How do we justify there's no for that?
We can do the limit from the left side first, and then we do limit from the right side. Then we compare the value. If the value is not different, which is in this case, then we can say it is undefined.
Okay, can you starting from the left, can you tell what should I write for the left, from the left side? Limit
x approaching 1 negative.
Yeah, negative sign,
fx.
What can you see from 0? Equals to 0. Everyone know how to see, That will be a 0 value, When your x approaches from the left side, your y is approaching 0. Correct. Correct. I would like to see this one. Okay. Then how about the right side limit?
It's approach 1.
Approach 1. Okay. I will show. We approach from here. We approach from the right side, which is from this point. Can you see or not? Yes. Okay. And it will be showing. It will be showing equals to 1. Okay, and then we have the left and right limit to compare, isn't it? Compare, and therefore we can write as because of x approaches from left and right, they are not equals, isn't it? Yes, everyone can follow? Yes,
Yes.
Therefore we can conclude that limit at that particular point does not exist. Okay, does not exist. Understand? Yes, yes or no?
Yes.
Sir,
Yes.
I want to ask why one negative is not answer equal to 1, is equal to 0.
Okay, you asked a very good question. That's a very good question. Okay, that means you haven't know how to see the graph yet. Okay, can you give me some idea that if I have a if I have a value here, let's say it is 0.99. So what do you see from? What do you expect to see their y value for this coordinate?
0.99.
Is it 0.99? If I make it bigger, like this, okay, this one is 0.
Oh, I know.
Okay.
Yes.
What is your y value? Can you see? Can you
near to 0? Near to 0.
Near to 0. You see or not? Correct or not? You see the y value is what? Maybe it's 0.01.
0.01.
Correct or not? Okay, I make it nearer again. Nearer again. Okay. 0.9999. It will be 0.001, isn't it? You can see the y is approaches what? 0, ma?
0.
Yes. Yes or no?
Yes.
Yes, okay. Can you stop? Can you don't unmute yourself? I would like you to answer another questions.
Okay.
Okay.
Yes.
Are we doing recording? Yes. Okay, wait for a while. Right. So how about the second one? Question C.
Question C.
Yes.
From
the left. How do you see from the left? To 2. How do we see from left? If I draw an arrow, can you tell the arrow? When I from the left side, when I have this limit from the left side, limit x approaches 2 from the left side, it is equals to what?
1.
1. You can see it very clearly. 1, isn't it?
Yes.
Agree or not?
Yes.
Yes. Okay. Then how about from the right side?
Also the same answer, 1.
Also the same answer, isn't it? Correct.
Yes.
The limit from the right is also equals to 1. 1. And therefore, the limit at that particular x equal to 2 will be
assist
will be equal to 1.
Yes.
Yes. Okay. Therefore, this is actually equals to 1.
Okay.
Okay. And one more thing to highlight. But you guys agree or not?
Yes.
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 Equals to 1. But F2 is what? F2 equals to what? F2 equals to 2, isn't it? Yes or no? Yes, and therefore, we actually can say that F is discontinuous. Discontinuous at x equals to 2, but the limit
Is 1. Oh,
the limit exists, but even it is discontinuous at that particular point, but the limit still exists. Understand what I'm saying?
yes.
Yes or no? Yes, sir?
Yes.
All right, okay. And
Sir,
therefore,
I don't understand, sir.
yes,
I don't understand how is it discontinuous at 2 and the limit is at 1?
sorry, come again. Your question is?
I don't understand this part. The f is discontinuous at x2. F2 is discontinuous at x2. X equals 2.
Okay, because the limit, their limit value is not the same. Because the limit x equal to fx is not same as f2.
Okay.
And therefore we can say f is discontinuous at x equal to 2. Okay, actually I would like to make a comparison. Are you Desmond?
Yes.
Desmond, hold for a while, okay? Hold for a while, okay? You don't unmic your mic first. I would like to have a discussion with you, okay? So if I compare these 2 points, okay, actually you're asking a very good question. Okay, that's the main thing that I would like to deliver to you all about the continuous kind of concept here. Okay, here. Okay, Desmond, can you answer question donkey first? Then I bring you back to the concept that you asked. Can you answer me the question donkey?
Okay.
From the left side, the limit is what?
2.
2,
Yeah.
And see, isn't it? From the right side,
also 2.
also 2, isn't it?
Yeah.
Yes, okay. Can you see that particular point here? When x equals to 3, your G3 equals to what? I mean your y, sorry, the y f3, sorry, the y. I mean the y equals to f3, isn't it? Equals to 2, isn't it?
Yeah.
Yes or no? Yes, okay. And the limit x approaches 3, fx also equals to 2.
2.
Yes or no?
Yes.
Okay. If we compare the limit value and the f3 value, are they the same?
Yes.
They are the same, isn't it? When this is same, we can say that f is continuous at x equals to 3.
Okay.
Because here we do not have the whole. If we have the whole, you understand or not? If we have the whole, that means we have a break. If we have a hole here, we have a break. Okay, that means we have a y at different value. Compared to this one, compared to this point x equal to 2, when x equal to 2, the y equals to f2, which is, what value is that?
1.
You know how to, f2 is 1. How to read this coordinate? 2, isn't it?
Yeah.
2, 2, that means your y is actually 2, isn't it? The y is 2, meaning when x equal to 2, the y is 2, correct or not?
Yeah.
Okay, compared to the limit value, the limit that you have found out just now by your friend, limit fx 2, is actually good. What? From the left and right, the approaches 1, isn't it?
Yeah.
Correct or not? Yes, So are they the same? Are they the same? 2 and 1 is the same?
No.
The limit x approaches to fx are not equals to f2, isn't it?
No.
Yes, no? Not equal. And therefore, f is not continuous. Understand?
Hold up. Trying to understand first.
Yes,
So
please.
if there's a hole, we must see the other one on top there.
Yeah. If there's a hole, that means you have a break. It's not continuous one. You have a break there.
So it is
You
see
have
the
a jump.
coordinate upstairs.
Yes,
Okay.
yes. When you have continuous that, okay, continuous that y equals to, I mean, x equals 3, y also having the same value. Okay,
Then
that'll
for
be
like,
continuous.
for like B just now, they are not the same also. What? So why is that
Yeah.
undefined?
Okay, for the B1, limit does not exist. The limit definitely does not exist, isn't it?
Yeah.
From the B1.
So if the limit doesn't exist, it's undefined. Okay.
The limit does not exist, definitely it will not continuous.
Okay.
You agree or not?
Yeah.
Okay. Can
Can.
If you have continuous, you have to fulfill 3 things, which I'm going to cover it later on. And I have recorded a video for that. If I don't have enough time, you can play my video for the 1.4 part. Will be more detail on this continuity.
All right.
Yes, okay. I think after my class here, even I can't teach until this 1.4 continuity. I actually have recorded a video which I'm going to share it in my Google Classroom. So all of you, please go through that video and then do the tutorial question. You have any question, please ask in the tutorial question, in the tutorial class. Okay?
Okay.
Can Okay, then how about Desmond? How about the last part? How about the last question E? Can you help to answer the last question E? Do we have the limit from the left side for 4? Question number, when x approaches 4? We have that or not?
I cannot see the question. Wait.
This one.
Uh-huh.
Go back to the original. Yeah. Okay, the same graph. The last question is actually asking about when this approaches 4 from the left side.
So it's approaching 1. It's approaching 1.
Yes, correct. Approaching 1, that will be here. Okay, if I ask one more thing, okay, if I ask another question, x approaches 4, do we have that limit?
No, because don't have the other coordinate.
Yes, because we do not have the right side limit.
Yeah.
Understand? We can write in this way. Okay, we can write, or because I don't have the right side limit does not exist, and therefore approaches 4 limit also does not exist. Yes, you can write undefined or does not exist. Also, I will accept.
Okay.
Okay. All right. Thanks for the discussion. Yeah.
Okay.
So everyone still have any question?
So that does not exist is if they are not the fx is not the same, it will have no limit. And then another one is when it doesn't have like positive and negative, right? And then you only have negative like going the left side and doesn't have the right side, so it also does not exist.
Yes, correct. Yes,
Okay,
correct. Unless the question asks only one side limit. Can you see or not? Unless the question only asks one side limit, which you can find it in the graph, and that will be axis. If you only ask approaches 4, because I don't have the right side limit, and therefore we do not have that limit. Okay? Anyone follow? Yes,
Yes.
Okay. All right. So now we continue. Okay. So sometime the question will come out in such a way that given a graph, isn't it? But however, I will not give you a graph. If I not give you a graph, you need to draw your own graph for your understanding. Okay? Like this question, the next question. Okay. All right. This one is so-called, is a name of this name for this function. This one is actually known as the piecewise function. Okay, piecewise function. That means for a different domain, it has a different graph. Okay, for the first domain, which is, if I roughly draw it here for your own reference, okay? for a domain of x more than 2, when x equal to 2, when I'm doing the substitution, I have 5, and then if I put 3, it will become 10. Okay, that means I have a graph like this. This is, I know it as, I name it as y1. Y1 is actually equals to x squared plus 1. Okay, for that particular domain. Anyone follow? Yes, for x larger than 1, I will follow this graph, which is the y1 is x squared plus 1. Okay, for the second one, which is 2x plus 1, the 2x plus 1 is actually referring to this domain, which is from -1 up to 2. Okay, and therefore, from this graph here, -1 up to 2, I have, you can put a table for that. Okay, say I have x is -1, 0, and 2. Then the corresponding 2x plus 1 will be this will be -1. Then 0 will be 1. Yeah, and then we have 2 will be 5, isn't it? 2 will be 5, okay? And therefore I have a okay, I have -1 here. Okay, this is hollow, and this is connected. Okay, you know why is it as a hole here? Desmond, you know why is it have a hole here? You know why is it a hole here?
No, not sure.
Okay, because I'm going to discuss because of this. Can you see or not? Is it include 1? Is it include -1?
No.
Not include, isn't it? Because when x equals -1, when x equals -1, what should we refer to? We should refer to the third function, isn't it? The third function will be this one, isn't it? This guy, isn't it? Yes or no? The third function is what? It's a constant function. The y is what? Y is always equals to 1, isn't it? Therefore, here only we have -1 and 1. Can you see it?
Okay.
Yes, and that will remain to the y number 3. The y number 3 is a constant function of equals to 1, and that will be having a point here, the point of -1, 1. Understand what I'm saying?
Yeah.
Yes, clear or not?
Yeah.
Yes, okay. That will be a piecewise function whereby we have to follow their corresponding domain, and I brought it for your reference. This one is y2. Y2 is 2x plus 1. Okay, and one of you follow? Okay, maybe we can do some discussion. Okay, this Desmond. Okay, so for 2 plus, for 2 plus, that means I'm going to referring to which graph? The 2 plus. If I have 2 plus here.
The red one and the blue one.
The red or the blue one? Which one? A purchase from where? From right or left?
From the right, from the blue.
From the right one means that whereby your domain, the domain of x is what? Larger than 2, isn't it? Yes or no? Yes, okay. When you see is positive, I'm going to substitute the fx to become x squared plus 1. That's what I'm saying? Yes or no?
Yeah.
Yes, because as what I seen from the graph that I draw for your reference, as I mentioned,
yeah,
this one I have a point saying that when I have some points, they are moving to the right, isn't it?
Yeah.
Really not. Yes, and therefore I'm going to substitute x squared plus 1 for this particular domain from the right side.
Yeah.
Okay. And therefore, for this function, we can just doing substitution of 2 squared plus 1, which is 5.
Mm-hmm.
Understand?
Yeah.
Yes, okay. Compared to the left limit, when we want to find the left limit 2 minus fx, 2 minus fx, when you see a minus sign on top of 2 there, this actually referring to x less than 2, isn't it?
Mm-hmm.
When x is less than 2, we have to refer back to this function, to this piecewise function, isn't it? For this range.
Yeah.
Agree or not?
Yeah.
Agree, And therefore, the function that I'm going to substitute for these cases, for this limit will be
2x plus 1.
Yes, correct. Okay, we have 2x plus 1. Everyone follow? Okay. Whereby now we also can substitute 2 into it. We have 2 times 2 plus 1, which is 5.
Mm-hmm.
Understand? Are
Yeah.
they the same? Are they same? Yes, Since they are same, since they are same, and therefore I will write such as, okay, I don't have enough space. Just write here this whole. Okay, I will conclude that since the left limit 2 minus fx equals to the right side limit, and therefore we can conclude that when they approach 2 fx, it does exist, and this value will equals to 5.
Yeah.
Can you all follow?
Yeah.
So Joe,
Sorry, I take some
what you
time to.
I didn't saw what you write.
I mean, take some time to loading. I'm still loading. Sorry,
Okay,
I take some time to load. I write it down already. Okay, take some time to write. Since the left limit are equal to the right limit, isn't it? Can you see or not?
Yeah.
You have to write this down. You have to write this down, especially for this kind of question. You have to write it down to show me that for your understanding that you have a left limit and right limit, you find them separately.
Yeah.
If you found that both of them are the same value, and therefore we just conclude that the limit exists, which is equivalent to their same value.
Yeah.
Understand, everyone?
Yeah.
Yes, Okay, when you work out this question, actually you do not require to draw the graph. I'm sketching a graph just for your understanding. It will be more understand what actually we are looking at. Right?
Okay. Can.
Right. So for the next one, okay, okay, I'm not going to refer to a graph. Okay, when we're doing for the next one, okay, for this guy, I mean for the next one B, question B, when we have -1, then I'll only refer to this domain. Okay, that means I'm only referring to this domain, saying that take some time. I think my connection is a bit slow. Okay, the limit. Can you see what am I writing or not? Cannot.
No.
No.
Wait let me rejoin back. Yesterday, that group also up to this point only, isn't it? Yesterday also I taught until this part, isn't it?
Yes.
For the DMG group. Also this question.
Yes. Yes.
Okay, for B. So for DMG group, maybe later you can refer back to the video I have recorded. Okay, I mean for the new things. I mean all of you have to refer back to the video that I have recorded. Okay, so for this -1 as long as there's a break, there's a break point here, we need to split into two. Okay, from the right side limit, if we want to find the right side limit, we are going to substitute the correct function, which is 2x plus 1 into this, isn't it? And that is how we get 2 times -1 plus 1, we get -1. All right, compared to the x approaches -1, fx, okay? While for the right side limit, for the left side limit, this is left side limit. You will refer to this domain, and that will be the corresponding function of 1. The x approaches -1, 1 equals to 1, isn't it? Okay, because both of them are having a different value, since we have limit x from the right side not equals to the left side limit. And therefore, we can conclude that limit at that particular point does not exist. Okay? Right, clear for you all? Can you all follow? No?
Yes.
Yes, Has any chatting? Sorry, I didn't check the chat. You need to write fully like that. Because I thought simply calculate, then shortcut straight answer. Okay, Chuan Hao, maybe we can do some discussion. What do you want to ask me about the about which way? About left or right? Chuan Hao. Working six marks. Which question about?
No, I just asked like for just to know only if the working really matters. So I was thinking if you calculate already on a piece of paper, then just can write the answer.
No, you have to show this working. If I want
Yeah.
us to find this one, whether it exists or not, you have to show us like, okay, say this one I give for example, this one I give 4 marks. For example, 4 marks for this question. I would like to see this. You are supposed to do one mark for here. Okay, and then here is 1 mark. Here will be 1 mark. I think 3 marks for that.
Oh, okay. Thank you, sir.
All right, you have to write this one. Unless if it is a graph, actually you are allowed. If there's a graph there, it's actually you are allowed to write this as well. Is it not? Okay, if it's a graph, then you may write also the left and right limit. It will be easily right. Same, isn't it? You do not need to do substitution like what I've done for question number 6. Question 5 is you have to write the right side limit as observation from what we have done. Here, isn't it? Fair enough. You just have to refer to the graph and write the final answer. That's it. Okay, but for this working example number 6, you have to substitute the correct function for that particular right limit and also left limit to find the corresponding value, compare and conclude. Understand? Yes, All right, I think I will. How many times I should have? Okay. Oh, now it's already continuous. So the next one, it will be continuous, isn't it? Yes. Okay, I think we can start at this point, because starting from this continuous, I have recorded a video. Okay, I think I take some time to upload the video first to show you, to show all of you where I upload my video. If not, later even I post something in my Google Classroom, nobody will see that. Okay, so now please okay, follow my, go to your this Google Classroom. Now I'm going to share my this 1.4. Okay, I'm going to show here 1.4 continuous. Notes and video. Okay, which means that like what I have did just now, when I record the video, also I have done some workings for you all to reference. Okay, so now I'm going to upload that video so that all of you listen now. Okay, you know where to locate that one. Okay, we have 1.4 continuity. I think we are okay. I copy the link first. Maybe I copy the link first for whereby I have uploaded my video. I have actually uploaded a video of this. Yeah, this is the one. 25 minutes. I think 25 minutes you can go and see. Okay, I copy the link first for this video. Okay, and then I can add some file for your reference, which is just now I have. Am I still recording? No.
I think no.
No. Okay. Where is it? I have done it here or where? 16. Oh, this one is today notes. Today notes. Okay, I'm going to search it out first later, but I'm going to post it here. So later, please refer to here to check this video. You can go and run this video. Okay, maybe I can share it now. So at the same time, I will search out the things. Okay, wait, I'm going to share this video now. Stop. So from what we have, the definition of number 3 here for the lecture notes, a function f is continuous. It's continuous as a number of conditions defined as below. First, the FC is defined. Okay, the first one, FC must be defined together with the limit must exist. Alright. And after one already reached the limit is also together. Why there's so many sounds? Okay, that will be the 3 conditions that where should I upload? Function. I upload the video first. The notes I will send later on. Can I? Sorry, I'm not sure where I upload the video. I upload the video first. That's the link. I post it first, and then I can run this one to share with you guys. Yeah, now I present again. You can try to listen now. So after we have learned the existing of the limit, now is 1.4 continuous of function. Okay.
Sir, I can't hear anything. The audio.
So The audio not
very
elimination of tree here of a lecture notes. Can you hear now? So after we have learned this existing of the limit, now we're going to go into this 1.4 continuous of function. Okay, continuous. So from what we have, the definition of number 3 here of lecture notes, a function f is continuous. Is continuous at the number of conditions defined as below. First, the fc is defined. Okay, the first one, fc must be defined together with the limit must be exists. All right, and the third one will be the limit exists and also together it is same as the fc value. Okay, that will be the 3 conditions that you have to fulfill 1, 2, and 3 to fulfill, so that it only can see it is a continuous function. All right. Okay, it must fulfill 3 conditions so that it will say that it is a continuous function. All right. Okay. So for this, whenever definition about how do we see the things? I mean the function whether it's continuous or not. Okay, so for example 1, the example 1 here, you can see that when the x value from the left side approaches and to the right side approaches a certain value, which is let's say it approaches an L value. So the limit when x approaches c value fx is actually showing that the y is approaches a certain value L. But however, at that particular point, we have the coordinate to show that the fc value equals to a certain value, say is a q value. Okay, that is a q value here. All right. So which means that the limit is exists, but it is not equals to the fc value because the limit x fx equals to L not equals to fc, and therefore this function f is also discontinuous, and this is this is actually a kind of a removable discontinuous. That is a whole in this case. All right, there is a whole in this case, and therefore the f is not continuous. Okay, for the first time. Yes, right. Okay, the second type is the right. Okay, when we have a positive sign, that means when the x is approaches from the right side to a certain value. All right, but this certain value is actually for example, is approaches to L. Okay, while compared to the left side limit, negative sign here means we will study.
Okay, the video gone.
Yes, hello guys. Are you there? Are you still here, everyone?
Yeah. Cannot see the video.
Yeah, I stopped the video for a while.
Yeah.
Okay. Sorry, I have other class going on after 6. So I think I start at this point. I have uploaded I'm going to show you again.